Let's solve question 4.3.6 in this video. Question 4.3.6. We'll go through A and B, and in the next video we'll go through C and D. So we're given a total cost function, which is equal to 200 plus 3Q, and we're given the price of what we're selling. That's 107 minus 2Q. So in question A, we want to know what is the total revenue. So how much money can we make? Well, total revenue is equal to the price times the quantity we're selling. So for every unit that we're selling, we're getting the price in return. Makes sense. So that's equal to price, but the price is 107 minus 2Q. So 107 minus 2Q multiplied with the quantity. Okay, and if we multiply it, what do we get? Let's multiply term by term. 107 times Q, and then minus 2Q times Q. That's minus 2Q squared. And that's it. That's our total revenue. Now, in part B, the question is, when do we have the maximum total revenue? So how can we maximize total revenue? Let's do it on a graph. Maximize total revenue. First of all, we have a quadratic function. So it's to the power of 2 with a negative coefficient. So let's just write that real quick. We got total revenue equals to minus 2Q squared plus 107Q. I'm writing it with a Q squared as a first term just to make it clear that it is a quadratic equation and just to show that the coefficient here is negative. So when we have a quadratic function, a quadratic equation with a negative coefficient, we have a parabola that looks something like that. So here we have our total revenue, and here we have our quantity axis, and it goes in this way. So it goes up and then it starts falling. And let's explain why this is happening. Does it make sense? Now, total revenue increases as we sell more. It kind of makes sense. The more we sell, the more money we make. But after a certain point, we could see that the total revenue starts falling. And why is that? Well, because as quantity increases, as we're selling more and more, our price goes down. We have to decrease the price to keep up with such volume, because if the price is too high, people don't buy as much. So we sell more, we increase the supply, as we say, and then we decrease the price. Well, in that case, if we increase the quantity and decrease the price, then we are starting making less and less money because the price is going down. So our total revenue starts decreasing. And that's what literally the graph shows, that after a certain point of quantity, as we increase the quantity, the total revenue starts going down. And now the question is, when do we maximize, right? When do we maximize total revenue? What is the highest value of total revenue? Well, let's look on the graph. The highest value for the total revenue is at the peak, because we're reaching the peak. We are here. That's the maximum total revenue that we have, and then it starts decreasing. So this is the value that we're interested. That's the total revenue max. Let's call it with a star, and that's the quantity that maximizes it. Okay, now what is this blue line over here? We call it a tangent line. Why is it a tangent? From the word touches. It touches the graph. It touches this curve. How does it touch it? Well, it touches at the maximum point. The tangent line is a slope to the graph. A slope to the graph is called derivative, right? Slope to our graph is derivative. Now, what is this slope? This is a slope, sorry. This is the rate of change. The rate of change. This is a slope. This is a slope. This is a slope. All of these lines are slopes. In these cases, the slope is going up. It flattens and then it starts going down. And the slope shows us the rate of change. The rate of change between total revenue and quantity. So how does total revenue change when quantity changes? Well, in our case, we get to a point where our slope does not change. It's just horizontal. There is no movement. So that means that the derivative of the total revenue equals to 0 at that point. So the derivative of the total revenue equals to 0. The total revenue derivative equals to 0. How do we call the derivative of the total revenue? We call it the marginal revenue. And why do we call it the marginal revenue? Because this literally shows how much more at this point the total revenue increased when we increased the quantity. So delta total revenue relative to delta Q. And if you remember in the first workshop, we had all this notion about delta Y, delta X, which was the slope. Well, that's the same. This is the slope, this is the Y-axis, and this is the X-axis. So it all makes sense. Now the marginal revenue. How can we calculate the marginal revenue? We have to differentiate the total revenue, which is minus 2Q squared plus 107Q. So let's do it. Minus 2Q squared minus 2Q squared plus 107Q derivative is equal to the marginal revenue. Minus 2Q squared, that's equal to minus 2 times Q squared derivative, that's just 2Q. That's just 2Q. Plus, what is 107Q derivative? That's just 107 equals to marginal revenue. Now, we want our marginal revenue equals to 0. So, marginal revenue equals to 0. Minus 2 times 2Q, that's just minus 4Q, plus 107 equals to 0. What is the optimal quantity? What is this value over here that maximizes our revenue? Well, that's equal to 107 divided by 4, which equals to 26.75. So when we sell 26.75 units, that's when we have the most revenues. We're done with these parts. In the next video, we'll go through C and D.